Hello, people. So, again, today we are going to have a problem solving session. For some reason, I only take problem solving sessions. So, yeah, let's just do the first problem. So, I remember someone asking, like, okay, I should not give out the thing, otherwise, it will be a little spoiled. But try this problem, tell me any ideas you get. And also, people wait for the people who are let a problem. Mm, yeah, this is cool. Yes, for the people who have tried that problem, try this problem. The second. Yeah, maybe I should switch it. Uh, yeah, yeah. So try the first problem and tell me if anyone has solved it before. Basically. Does everyone understand the problem?
Yes.
Nice, nice. So humans, any ideas? Okay, wait, did the sharing stop? Yeah. Is it visible?
Yes.
Yeah.
Nice. Yes, so any ideas? Like, what are you thinking?
Bipartite graphs, perhaps?
Interesting. So, one side boys and the other side girls, I assume.
Yes.
But how would you like keep track of at least half in this case?
Like you could take some sort of complement, right? Like There's be half, like if we could take like two groups and then we could somehow make one group completely even, then the complement or somewhat a complement idea we could use, and then the other is more than half.
Wait, I don't quite get you. What do you mean? Like,
Like I thought,
you have this, like, say you have like four boys and five girls, and like each boy likes some girl. Uh, and this, maybe this, and yeah. So now, like, what were you thinking?
I was thinking like, I mean, it's not a concrete thought, like, so I
Hmm.
was thinking like we could take some sort of, like we could take one group and the complement of that group, like all the boys and girls not in that group, and then which of the groups is greater than half, we could like consider that group itself and then find out if it's possible that there's not number of
Okay.
girls. Or we could like we could remove a boy and a girl, or a girl, to to try making it odd in some manner.
Yeah, so like for both of these conditions, you would have to look at like the number of like the degree of the girl and the boy, right?
Correct. The degree of the boy.
Yes.
The degree of the boy.
But that's something we don't really have much control over. Like, uh, it's like totally possible for like a so like you don't really have the control over that degree, right? So
Okay. So you're saying like we have a control over the number of some sort? The
yeah,
number
not
of boys
even
and
yeah,
girls
no,
we take?
no. I meant like you don't you not only do you not have control over the degree, you don't have the control over the neighborhood, right? Either. Like you can't
Okay.
like
Yes.
yes, because when you delete a girl, okay, deleting a girl is like get the point.
Yeah, yeah.
So like when you delete a girl, it's like edges are also removed, but you don't know how many like and it's totally possible that some of the edges which are removed were inside the set you originally took and some were not. So like you don't
Oh,
have the control over the neighborhood. So you like if you are looking at degrees, you should probably consider neighborhoods.
okay.
Wait, I didn't quite understand that neighborhood argument again.
Nahi, like I meant ki say that like this girl, like and this is the case. Okay. So
Right.
for like a general graph, you can't really say ki what to look at, right? Means
Hmm.
you don't like if I delete some girl, then I don't know ki how the degrees on the boys side will be affected. I can't particularly say that. Matlab, the neighborhood, some part of that girl's neighborhood would be in the set that he chose, while some would not. And choosing that would be like getting a good control over that is hard.
I see. Okay. Yeah.
Yes, like usually you should like try to look at objects which you have control over, because if you don't have control over, you can't use it nice.
I was trying to work on the parity of the number of friends one boy has.
The number of friends a boy has. Okay, and how do you intend to proceed?
So, like, suppose we have n boys, and since each of them have uh, like they know at least one girl, so you can give all of them, but you don't know if they share the same friend.
Mm-hmm.
But then once you can kind of see that since you're working with an odd number of girls in the group, suppose each boy had an even number, and then you can kind of remove one girl from from that set. So try to like I'm trying to construct the group itself.
Yeah. That's a good idea. That's a good idea to look at. But like, see this. You are given like with respect. So you're given two things. Like with respect to each boy, you would have like some set of girls like G1 or like some stuff which he
Yes.
knows. And with respect to each girl, there would be a set of boys who know the girl.
Hmm.
So which one of these two do you think is like more? usable, or like you have more control over that in
I
some.
think it's going to be the B equal to C first.
This one.
Yes, because we know there's at least one over there. At least, like, there
Interesting.
could be a girl who has no friends at all.
Yeah, correct. That's very good. So you would ideally like to construct a set of boys, right? Because you
Yes,
have more
yes.
control over them. So if you have to construct a set of guys, pick a set of girls randomly.
Okay. Okay,
Okay,
fine.
so that's like okay, people didn't ask for a hint, but here it is. Pick each girl with a probability of half.
What's this probability? What's the probability of? It's the probability of which event?
She's in the set. Like we have to okay, so this group, right?
Yeah.
We have to consider this group. Pick each girl with a probability of half. Like the event is that she is in the set. The
Okay.
probability that the girl is in the set is half.
No.
Yes. Wait, so like does everyone understand what I was saying? Like do you get why we picked, like, firstly, why did we pick uh girls instead of boys randomly? And why with a probability of half? Do you get that?
The half makes sense, like because we have at least half students, that makes sense. But uh, the fact that we don't know much about how many friends each girl has,
Hmm.
that would rather be a bit cumbersome to start with a group of random
Yes.
girls rather than a
So
group of random boys.
no, that's the point now. So uh don't look at like the like you have this set already. Okay. Don't care about this anymore.
Okay.
Now you have like sorted the girls out. Like you have picked like roughly say the number of girls was G and the number of boys was B. Then you have roughly picked G by two people, right? Like this is the expected number. Like it's about this. Okay.
Yeah.
You have picked your people from girls. Now don't look at girls anymore. Now we picked them randomly. Now look at boys. Like if you have G by two, what's the next constant you would want?
The number of boys who like those girls or
Yeah,
with
like
those girls.
yeah, but like if you see the total number you need is B plus G by two, right?
B by two boys
Yeah,
of some boys, B
exactly.
by two.
Yeah,
So
yeah,
again,
yeah, great, great. Yes, continue.
so again we can take like each boy with probability half, or should we like do we have to
No,
consider
you
uh,
can't take both with probability half because
because then
like
it'll become a random completely. Yeah.
huh, exactly,
Uh,
exactly.
There's no
So
point.
yeah, but that is good. Like even for boys, now you need the new constant that you want is B by two, right?
Roughly, yes.
Yeah. So try to show that the probability that a boy, like some boy is selected corresponding to this group that we have picked is also half. Like you have this group of girls like G1, G2, and like blah blah blah. So and there is this boy B1. So what is the probability that he is selected? Like what is the probability that he has an odd number of friends inside this?
Half, right? Because it can either be odd or even, and
Yeah.
it must be equal somewhat. I mean, exactly equal.
what must be
Wait.
equal?
Uh, wait. What?
No. Wait, let me just confirm my thinking.
Yeah. And Ronit, what were you saying?
No, I was just asking what he was thinking was equal, but I think it's that confirm his theory.
Yeah.
Can you please follow up from the start? I'm not able to get how probability came and I'm not able to follow up actually.
Huh. Yes. Yes. So see, what we observed was we essentially have these two sets. A set like with each boy, I could look at the number of girls he knows, or with respect to each girl, I could look at the number of boys who know the girl.
Yeah, yeah.
Yeah. So then we saw that the first set, which the first set was more usable because we know that the mod of each set is at least like the number of people in that set is at least one by the given condition, right?
Yeah.
Yeah. So then, yeah. So after that, what we had was like we saw that we had good control over the boys. So we need to somehow treat the girls. So we need roughly like a G by 2 constant, right? If the total number is G, then we roughly need a G by 2 constant, right?
No, I'm not able to get this constant.
Okay. See, so like we need like half the students. Okay, at
Yeah.
least half the students, right? So now the total number of students is plus the number of boys. Not doing any like 21st century like, yeah, homosexuality and all that. It's like
Oh,
girls
the
and
voice is
boys.
breaking.
So, Lavish, does that make sense?
Your voice was cutting. I couldn't get that part.
Yeah, we can't hear you.
Is it audible now, people?
Yep.
Yeah. So, Lavish, do you understand like the total number of people has to just be like G plus B, where G is the total number of girls and B is the total number of boys?
In the group we actually want to construct.
No, like let the total number of girls in the school be G and the
Okay.
total number of boys be B. So the total number of people in school is G plus B.
Yeah.
So we need our group to have at least these many.
Yeah.
Now we observe that we have like good control over boys because we know how they work, right?
Okay.
So now we don't have a control over girls, so we just picked half the girls at random. So we picked each girl with a probability of half. So we would like the expected value of girls chosen is G by 2. Means like
Okay.
if I pick each girl with half a probability, I would expect about G by 2 girls to be selected, right?
Yeah. Yeah.
So did it make sense now?
Okay. Yeah.
Yeah.
Okay, so now since you've chosen each girl like with equal probability, like the chance of her being chosen and not chosen, the chance that the degree of the sorry.
Sorry, this was another. Wait, did I just close the? Okay, I just closed the OneNote. People, just a second.
Okay.
Yeah, you can continue speaking. I'm listening.
Okay. Where was I? Okay, right. So the since you got a equal probability of choosing and not choosing a girl, the
Hmm.
degree of the boy also has an equal probability of being odd or even. Roughly, it depends on the total number of the at the starting degree, but roughly it's equal.
True. True.
So, so if it's half for each of the boys, so there's a probability of half for choosing each of the boys. And again, by the expected value, can't we not claim that b by 2 boys must exist or roughly must exist?
Yeah, yeah. Your idea is correct, but how should I say this? Like you should say it better. I think. Like I did not really understand it. Could you repeat?
Okay, fine. So,
So you're
um,
saying that like each girl is picked with the probability of half.
which is equal. So each
Yeah.
boy itself has an equal probability of having an odd number of girls or an even number of girls.
Why?
Because each girl in his liked set or whatever known set has a
Hmm.
probability of being chosen half.
Hmm.
So similarly, the chances of it being odd or even must be half or equal.
Yeah, that's correct. Wait,
So
do
again,
other people? Huh, yes. So again, we would expect the number of boys to be like roughly B by 2. So the total sum we would get is at least B plus G by 2, and we are done.
I'm just a little bit not so sure, but can we talk about expected value like this though?
Uh, like, yeah,
Because
I
you're saying
don't
roughly
really.
and approximately, like
Oh no,
I'm
not
not
roughly and approximately. So like then okay, so you could write it like this. So
like
the number of like expected value of number of girls is equal to uh the sum of the expected value of some girl G1 GI,
each
where I am
girl.
summing
Yes.
over all the girls.
Yes.
Now each girl has an expected value of half, like the
Half.
probability of half of being
Yes.
selected. So this is just the number of girls
Yes, yes. This is correct. This is G by 2.
over 2. So that's like G by 2. And then like you now you see that now for each boy you could look at all the wait, no, like why does it not work? Like I don't understand what you don't understand. Like what's the issue, I
Like
mean?
I'm wondering if there's an edge case that we can't handle because we're taking expected value and that's related to probability. We need to prove that the group completely exists. So I mean it could be an issue on my side also, but yeah.
Uh
I think I'm also kind of stuck at that point of how you can see that B over two girls must B over two boys must have an odd number of girlfriends in the set. In suppose your set of girls was S, not all girls are ones you've chosen, those G by two. So then
hmm.
I take every boy, then the chance that he has an odd number of girlfriends in that set S is a half. But how does that constitute to having B over two? And I think that's what Nishant is saying. If suppose you have an edge case where it's not B over two but something less.
Yeah.
Oh no, it won't be that now because oh see, so that's the point. So we are not okay, I get it. See, so what linearity of expectation does for us is it looks over all the possible cases and gives you if it's possible to achieve some bound. Like it won't look at one particular thing and tell you something. What it would do is look over everything, like all the possible subsets, and show that like is some value attainable. So what we did was like look over the entirety of this thing and show that we could pick B plus G by 2 people. Like over all the subsets which satisfy the value, like which satisfy the condition that each boy likes an odd number of girls, there is some set that has B plus G by 2 value.
Can you please tell what is expected value? I forgot. I learned once, but now I don't remember it.
Okay, so you don't know expected value. Fine. See, so let's say yeah, so say that like you have a dice which has the numbers 1 2 3 4 5 6. Okay, you randomly roll a dice. What is like the like what value would you expect it to be? Like if you ran like if you rolled a dice, what value would you expect to get?
Was it the probability average of the probabilities of every?
Yeah, so it's like you take each number, you take the number 1 and multiply it by the probability that it will occur. Then you take the number 2 and multiply that by the probability that it would occur. And then you would do this for all the numbers. So you would get something like 15. Okay, wait. You would get like 1 plus 2 till 6 over 6,
Divided by 6.
which is like 5 by 2. Okay, sorry, 7 by 2. Like, uh, so this is like you would expect some value close to this. It would mean like if you randomly throw a dice, you would expect some value close to this.
Right. So you said expect some value close to this, right? Like so here in the expectation, what if you get like G minus 1 by 2 and then B minus 1 by 2? How do you know for sure that it must be G by 2 or B plus G by 2?
Okay, wait. Then on this you can apply PHP. ठीक है मतलब यार wait, how would I tell this? Like so I'll like give you a brief overview. So what expected value does is that it looks over all the possible cases and presents to you some data. ठीक है? Like then what you do is you apply PHP to this data. So you get the upper and lower bounds. Matlab,
So how do you use PHP here then? If you're getting
nahin, that's the point. You don't explicitly use PHP.
okay.
Linearity of expectation does that for you.
That is weird, but okay.
Indeed, it is very weird. Wait, but like, do people understand how we got b plus g by 2? Or like, I'm sorry, I'll try to explain this better towards the end of the class, maybe.
That's the
Sorry.
expected value, I get it, but I still don't get it. That's the explicit. We'll explicitly have a set greater than equal to this. That's the part I'm struggling at.
We are actually like summing over all the possibilities. So if the expected value is like b plus g by 2, there should be one set where it is greater than it, at least by PHP argument.
Okay, then yeah, okay, yeah, that's right. That made sense. Yes.
Thanks, Saritra. And like Nishant, like you said, it's the average of all probabilities, right?
Yeah,
And
yeah. So
like,
there's
if
one
it's the
probability
average, there
greater.
has to
Correct.
be some value above.
Yes. Oh, right. Okay, that's
Ah,
where I was putting. Yes.
yeah.
Thanks a lot.
Thanks, Aritra came in clutch. Great. Yeah. So like, does everyone understand what just happened?
Yeah. Now that PHP thing makes sense.
Huh. Nice. So maybe let's just go to another problem. Uh, okay. Yeah, this problem should be good. So find all polynomial p such that okay, integer polynomial, find all integer polynomial p such that uh, you consider the numbers of the form p of 2 to the n belonging to the naturals. This, like all of these numbers have such that wait, how do you write numbers of the form this have no prime divisor greater than 10 to the 100, or like any large constant for that matter, it works. So like is the question clear?
Yes.
Nice. So yeah, right. And it's not a like random probability thing. In fact, I think someone asked for size issue stuff, so
That's
this
the
would, I think,
size, right?
yeah, I think this would fit the description.
So there is an upper bound on the on the max prime divisor of all the numbers of the form p raised by 2 raised p 2 raised per n, right?
Yeah.
Mm, okay.
Do we need like any advanced like theory, like some theorem or something?
Uh, no, I won't call that advanced, but say this. Do you know this thing? Uh, if x is congruent to y mod p, in fact n works mod n, then px is congruent to py.
Yeah.
Yeah, factor theorem, I think.
Yeah, this is obvious.
No, Aritra, it's not Schur's, because Schur's talks about general p to the n. It does not talk about p to the 2n. But the idea is very similar to Schur's, I would say. Okay, I should not have said that.
So we have to find some sufficiently large prime which divides some polynomial p of 2 to the power n.
True, but can you do that? Is
We
the
need to find
question.
infinite primes, not just any.
Yeah, you can find infinite primes, but like you can find infinite primes for p of n, not p of 2 to the n. Like you can find like yeah. So wait, firstly, people, what are your guesses on this polynomial? Like, what do you think is a polynomial that satisfies this?
X. P of x equal to x. I'm not sure. Yeah.
Constant polynomial.
Yeah. P of x equal to x also will, right?
Okay, such that okay, wait. So another condition, p0 is not 0. Yeah.
Yeah.
Okay, sorry.
That's what I was wondering.
Yes.
Then like Aritra said, like constant, I guess.
Yeah, constant polynomials do work. It's very good. And wait, just to check if I'm not doing some mistake, I'll look up the exact problem as well. Wait, Aritra, how do you intend to use Dirichlet over here? Okay, people, let me check this. Find all non-constant
Should I
humans
say?
such that. Okay, humans. Actually, what we can do is like, wait, let me think. Yes, you can actually let p0 equal 0 and you would just get more stuff. Yeah.
We'll just get like x, p of x equal to x.
Yeah, p of x is x or p of x is cx
Yeah.
works where c has no prime greater than.
Yeah.
Yeah,
Kx.
Aritra, continue.
No, I thought like you could do this thing, px congruent to py mod n, and add something like 2 to the power n plus prime into some like ap thing. So it would have like infinite primes because Dirichlet, and then use like some kind of scala. I'm not sure. I'm just idea.
Wait, but 2 raised to the power n does not have AP. And like a polynomial need not be AP either. Like x square is not an AP.
No, 2 to the power n isn't a AP. I'm talking about adding primes to 2 to the power n in a constant basis, like 2 to the power n plus p plus 2p plus 3p, like that.
Interesting.
Okay.
But reducing this, like, you can reduce the power mod like p minus 1, right? If we take some prime, some large prime, like we can reduce the power mod p minus 1. So
Hey, that's indeed a good idea. That's indeed a good idea. Try to think about that. Like, how could you use that? And am I audible? Hello.
Yes.
Huh.
so the multiplication of the number, okay, yeah, we can multiply. I will leave it. Doesn't matter. Okay, I'm just like, I want to check, but does k into x to the power n work?
What?
Like p of x equal to k into x to the power n, where k is has some prime divisor less than 10 to the power 100. It should, right? Because it's only two.
Yeah. It does. It does. It does. It does.
So now we can just assume that p of 0 is not equal to 0. Or can, yeah, because then we can just ignore the x power, like x. If there's some x to the power n multiplied by such a polynomial, then we can just ignore all those x's because they'll just contribute powers of 2.
Yes, but yeah, you can assume that because they only contribute. Yeah, so you can assume P is not 0. What next?
Wait, I didn't quite get that other terms thing. Could you repeat?
Oh, yeah, so he meant that assume that P0 is in fact 0.
Okay.
So you would have that Pn is equal to n times of some Qn, right?
Huh.
Now you can divide this, like if this Qn is divisible by n, again you could like take the factor of n out and you do
Huh.
this k times. Okay, let's write this one. Yeah, till you reach a polynomial which is no further divisible by n. Yeah. So essentially it
Okay.
has some constant term. Okay, it has some constant term. So because all polynomials of this form obviously work, where like k has no prime factor greater than that.
Right.
Yeah.
Okay.
Yeah, I'm just curious.
But do you
Sorry.
need to go through these steps to show that k times x to the power n works?
No, you don't. Like kx to the power n obviously works.
Yeah, exactly.
Yeah, that's
Like
why I was
kx to the power
also.
n obviously works. We want to like talk about other polynomials now.
So I
What
was
other
thinking.
polynomials might work? Yeah.
So I was thinking, like, is 2 a primitive root mod infinitely many primes? I'm not sure.
That's actually one of like it was a conjecture by R10. It's an open question.
Oh, it's open. Ah.
Yeah, pretty soon. Like I'm pretty sure I also thought like of the same question in some question. That is why I know that.
Or we could consider a primitive root of some large prime above this, and then write 2 of in that some form of that. I don't know.
But would you be able to prove that? Like, is it possible to show that?
Sorry?
Like, can you show that? Like, like for all this, there will be some this, that will be that. Okay, wait, that made no
No.
sense.
Primitive roots exist for every prime, right? So
Yeah, but how can you show that 2 to the n will always be a primitive?
no, I'm not saying 2 to the power n is a primitive root. I'm just saying there'll be some g. There'll be some g which we can write 2 as the form of g to the power a. I mean g to the power, okay, we have used x, right? So g to the power a or something. I was trying on those lines.
Wait, I don't really get your argument. What do you mean? So you take like a primitive root g for a prime p, you take this primitive root.
Sufficiently large, yeah, whatever. Then
Yes.
you can write 2 as g to the power a for some a.
Okay. Yeah, so you get like a p of g to the 2a. Okay.
Okay, and wait, 2a? Okay, fine. I mean, not really. We'll get g to the power just a, right? A into n.
Sorry, a into n. Yeah, a n.
And
Yes.
eventually it'll repeat. Like because if x is congruent to y, g to the power an will be congruent to g to the power an minus.
Yeah, it will repeat. Very true.
So we can
Uh,
just like take only till that much. And then we have to
yeah,
talk.
or huh.
I was trying to figure out the constant term. How could we bring in the constant term?
Okay, I don't think. Yes, that is a good idea. So like in general, if you have like p to the 2n mod t is
T or
just
whatever.
congruent to like p to the k. Okay, wait, p to the like 2n mod t, right?
N mod T minus 1?
Like,
Okay, 2 N mod T. Yeah, fine,
okay,
fine, fine. Correct, correct. That's right.
like, yeah, like this, where k congruent to 2 to the n.
Yes, correct, correct. That's what you've written there.
Yeah.
Yes.
How do we know this again? How do we know this for certain?
Wait, this xy thing, this thing.
I'm like, okay, then BX.
Okay, wait, do you want the proof for this thing? Are you asking for that?
No, no, no. No. Maybe we can get it in that. Yes, okay, I see. Yeah, right, right. Direct application.
Mhm. Yes, humans. So, any thoughts or whatever?
I was thinking what would be a good T in this case so that we can use it.
Hmm.
I thought about t is equals to p plus 1 where p is some prime dividing n. I'm trying to follow it up now.
Yeah, that's nice. That's nice.
If we put t is equals to p plus 1, so we get like k is congruent to 1 mod p plus 1. Okay, but
Technically, we need to prove that P of 2 to the power n, like the if you take a product like of all of them, is the product of all of them is divisible by infinitely many primes, right? We have to prove that.
Yeah, that would be true. Like, that would be sufficient.
But I don't get it how we can.
Yeah, that's the point. So, like, think in this way. We have this condition, right? That p of 2 to the n is some smaller guy,
Yeah.
right? So, can you bound this quantity, like p2 to the n? Can you bound the VP of this thing?
It's, I mean, okay,
Or
the
in
minimum.
general, like some Vn? Can you bound the Vn of p to the... Okay, wait, do you think that any polynomial that has multiple terms of x works? Like, for example, x square plus x. Do you think this would work?
No, because just if you reduce it like x into x plus 1, so x plus 1 most likely won't work. We haven't proved
Okay,
it till
so
now, but
like,
I
yeah, it won't work by say Kobayashi or something. So would
one
this
second.
work? Would this
why
work?
won't that work? I didn't get it.
X plus 1. Why won't x plus 1 work?
Yeah.
Okay, so you could take any, so for any prime p, 2 to the, okay, so this just requires 2 to be a quadratic residue. Wait, do you have any idea about quadratic residues? Okay,
No.
even better, like let's just not get tangled up with x plus 1 right now. When we do the proof for the other stuff, we will directly get to that.
What did you say? I just missed it. You said x square plus x, right? I got that part after.
Yeah, my question is, does x square plus x plus 1 satisfy the given condition?
Most likely no too, right? Because
Why? Like, don't give me a proof, give me like a good enough reason to believe that it doesn't.
isn't it just 1 added to x squared plus x? So I mean, it's an AP, or is it? Wait, so
Okay, in fact, wait, this is like a bit of cheating. I can't do that. So instead, like I give you the claim because this is a very useful thing I want you people to know. So what you can do is find some quantity t such that find t such that p of 2 raised to the power n plus t is congruent to p of 2 raised to the power n mod t. Can you find such a quantity?
it used t twice. Is that a variable issue, or is that just
Okay,
the
no,
way it is?
I meant p. I meant p. Sorry, p.
Okay, so p
Can you
minus
find me
1,
such a t?
p minus 1, right?
What? Yeah, great. P minus 1 works.
Yeah.
Multiples of p minus 1, whatever.
Yeah, true. Now, so assume that P only had like some limited prime factors.
P
Okay.
had a limited, as in?
P 2 raised to the power n had limited number of prime factors. What?
Correct. Fine.
What? Wait, am I audible?
Yes,
Yes,
yes.
yes.
Yeah, so like what were you saying?
I mean, what did you want
Yeah,
us to?
you.
Okay, we're assuming p of 2 to the power n has limited number of prime factors. Then, so if you reduce the in the
Can you
power,
do the same thing here? Like, no. My question was, can you do the same thing here? Like, you did this, you could do the same thing with the VP, right? Like 2 raised to the power this p 2 to the n for mod p square. Can you find such a t?
phi of p squared, right? So that's p into p minus 1. So you can wait. You phi
Yeah.
exists for that reason.
Yeah, what?
Phi. I mean, Euler tangent or whatever you want to
Yeah,
call it.
you could take the phi. Correct. So in general, if I replace this 2 with some k, you can
Okay,
still
k.
do it,
Fine.
right?
It'll still work. Yes.
Yeah.
Yeah.
Since we have
So
freedom. Yeah.
now my idea is, so what the idea will be, you look at this set, okay, and what you do is that there has to be some uh maximum prime factor of each thing, right? Like there has to be some maximum prime factor of each thing, or in fact take a general p to the 2n. Okay, let this equal p1 k1, p2 k2,
Yes.
pt kt,
PT, KT. Fine.
where p1 through pt are all the possible primes that can divide p of 2 raised to the power n. Like we assume that they were limited, remember?
Yes. Yes.
Now you have this. So can you somehow find me a t such that p of 2 raised to the power n plus t is congruent to p of 2 raised to the power n modulo this quantity? Like, do you,
Okay.
Modulo what?
Wait, so modulo P of 2 to the power n, you're saying?
So P2 raised power n plus T must be 0 mod.
what I want you to do? Okay, so like broadly the okay, wait, am I audible?
Yes.
Yes.
Yeah, sorry, my internet is just horrible today. So my screen is also not visible. Sad. Yeah. So what I want you to do is this polynomial p. As it's non-constant, it will grow arbitrarily large. Do you see that? Like I can achieve any large value I want with this polynomial p.
Yes.
Yes, yes.
Yes. So what I will do is by this congruence, I will bound its VP. Okay.
And the thing you're putting in open brackets is P of 2 to the n, right?
Yes. Yes.
Okay.
So
So
you want
what?
P of 2 to the power n to divide P of 2 to the power n plus T.
What?
You want P
No,
of 2.
just that.
No, I don't want that. I want you to find me such a T that I can bound the VP. मतलब देखो VP of I whatever like PI
Whatever,
has
fine,
names
fine.
in it. Like VP of 2 raised to the power n plus k
Huh.
is equal to VP of okay yaar, I have to write so many P's. VP of P of 2 raised to the power n. Okay, I want you to find me such a K such as this holds. P sub I. So, and do you see how this problem is just related to this exactly?
Yeah, because you can take the phi of the phi of the PI, right? Wait, no, phi of
Yeah,
PI
you
to
could
the
take
maximum
phi
power, which
of,
is present in P of 2 to the power n. Hello?
yeah, no. You would do that for k plus 1, right? Like if the maximum power here for P1 is k1,
Yeah,
then I would do that for
K1 plus
P1
1.
k plus 1,
Yeah.
k1 plus 1. Does this make sense? Why?
Wait, what does that P1 K1 plus 1
Oh,
do?
this is just P of 2 to the n. This is P of 2 to the n.
Right, that's P of 2 to the n, but then that this quantity we know is not going to be a part of P of 2 to the n because it has an extra P1.
Yes. So I am doing this extra P1 so that when I take this quantities like phi, okay,
Yeah.
what
So,
happen when I take this quantities phi, what happens is that the congruence P of 2 raised to the power n plus k congruent to P 2 raised to the power n holds mod P to the k1 plus 1, and as it holds p1 plus this, it would also hold mod p to the k1. So if it divides k1, it would also divide this thing, but as k1 doesn't divide this thing, it won't divide this thing either, and hence the vp would be conserved.
fine. Yes. You
Nice.
can find such.
So,
Roll other people, does it make sense?
not exactly, just going through it. So you're
Oh
saying that you take the P of that,
yeah.
and that's going to be, but that's not a part of P to 2 to the n. Sorry, I'm coming back to this one.
No, it's fine. See, so what do you understand that I want to prove this?
Huh.
Okay, so for that, I would look at this quantity first, like phi of this thing, P1 K plus 1, where K1 is the VP of this, VP1 of
Right,
this.
okay, you're taking n plus k, huh?
Huh. And I do this because now that I do this, matlab, say that I let this be K, so this congruence would hold.
Yes, yes.
Yes.
Yeah.
and as k1 as p to the k1 divides p to the
So
k1
VP is
plus 1.
conserved. Oh,
Ah,
okay, yeah.
yes, precisely.
So now we
Now
can
that
finish because of the VPs are going to stay the same or are bounded. The numbers will get arbitrarily large. So you can't have
yeah,
finite number
that's
of
not
primes. So it'll become must become infinite. I mean, it'll
true,
become
precisely. Yeah,
Like it will go above your
precisely.
value.
Yeah, very true. That's exactly what we will do. So like for all pi, like in pi that divide p to the 2n, you can consider the phi of whatever this quantity is, 2 raised to the power, no, not 2 raised to the power, uh pi raised to the
value
power
to
v pi of
okay. That's
p2 to the
okay. That's a
n. Yeah, this is like horrible stuff, but this is like you will have to. This is like the easiest way to write it. Okay?
okay.
Like you consider this for all primes and then you just multiply it. Okay? Like because you want it to be true for all primes
True for
pi.
all. Yeah, true for all.
And then you just multiply it by some constant k as well. Do you and like
To make it
why
go
we
large.
multiply?
To make it large. To
Yeah,
make it large.
precisely to make it go large, we multiplied by some k, and then when I raise n, wait, sorry, when I raise 2 to this entire thing, the VP will be conserved. Okay, it's horrible looking, I know, but yeah, when
Yeah.
you
It's just,
raise to, yeah. So then the VP would be conserved, and hence it won't work. Did that make sense?
yes.
Yeah. Makes sense.
Ah,
Okay, so we
great.
looked at V, so we kind of did a contradiction, right? So we looked at the PIs, we assumed it to be finite, and we looked at V of PI because
Yeah,
it's finite when we can somewhat control it.
precisely. Nice. So wait, like we still have time. Wait, how much time do we have?
Yeah, half
So
an hour.
yeah, we have half an hour, and we can possibly extend it like 5, 6-ish minutes. So do you want to do a combo or a geo? Your choice.
GU, I don't know.
Wait,
Geo,
people
Geo,
like
Geo.
Yeah.
geo. Okay, so we have like vote for geo. Like if no one else is voting, we would do geo.
I
Oh,
think
I
Aditya
vote
also
for
wants that
combi
combo.
actually.
Okay,
Okay.
there is like vote for combi. There is one vote for combi, one for geo. We need
One more for
votes,
Geo.
people.
One more for
One more
Geo.
for geo.
Okay, 3 to 1.
See, so
I think that's
like
it.
Aritra, it's just one-sided. We can't do anything. Sad.
Sorry, Aritra.
Sad
Finally.
indeed. Finally, like Lavish on his revenge arc. Wait, so people, let me like find a problem. So I think I have a problem which I had in mind. Okay, in fact, there is also this interesting problem which we could do potentially. Oh, also, like, what are you people's thoughts on Bash?
If the setup is nice, Bash is nice.
Sorry, could you
Okay,
repeat?
so what are like your thoughts on bashing? Do you think
Nice.
bashing is ethical?
Yeah, I
Yeah.
know, Nishanti,
Nice.
you'd say nice only.
Obviously, like, I mean, there's an art in bashing itself, right? Like, you have to set it up. If you set
It
it up
can
right,
be beautiful
Synthetic is
sometimes.
too old.
What?
Like it's just natural. Synthetic is just natural.
True. I know that there are many people like who are like against bash.
It can be beautiful sometimes. Yes, there.
I don't,
Sometimes.
but
Oh,
sometimes
let's
seems
just
like,
do like this is the
yeah.
perfect problem. Let's just do a bad thing. Okay, wait. Do you want to do a good problem or a bad problem? Wait, what are you people able to see right now?
Yeah,
Uh,
the VP stuff.
Okay, then it's fine. So yeah. So do you want to do like a good problem or a bad problem? It's your choice.
What is
Like
the
what
no,
meaning
Can
not
you
of good
bad.
and
define what
bad?
is a good problem and what is a
Yeah.
bad problem?
exactly.
Okay, so people here are quite educated, I see. So a good problem, I would say, it's not bad, it's not routine. So like the one problem is like some normal stuff you would always see on a geo problem, and the other thing is more like geo non-routine geo, I would say.
Non-conventional. Geo.
Yeah, non-conventional. Yeah, that's the word. That's the word. Non-conventional geo.
Let's go with the bad one.
Coin toss.
Okay,
Non-conventional.
that's actually a good idea. Wait, let's just coin toss. Let me tell Google to coin toss.
What is
So
this?
if it's like heads, we would do conventional thing. Else tails, we would do this. So
Okay, we need to
coin
see the
toss.
Google webpage, otherwise there's no bias.
Oh, okay.
Nah,
Wait.
it's no,
I
no, no,
will
no, no, no.
share
Trust
that.
you. We trust you, sir.
Yeah,
Very
Have some trust in your
nice.
teacher on
Mine
it.
doesn't.
Shameless brat.
it was a joke. It was a joke.
Oh,
Yeah. So is it visible, people?
bro, it's showing tail.
So like let's just flip it. Let's see. Heads is conventional, tails is
I think it's
non-conventional.
heads. Oh heck, it's
It's
tails.
tails. We will do the non-conventional geo people.
Yes, I said the bad
Quickly
one already.
save your time. Let me switch back to OneNote.
Wait, so this is
Yes.
construction or
So
what? If it's
it's
construction, that'll
not
be cool.
construction. You will see what it is. You will see what it is.
Okay.
It's
I
a
think it's gonna be
fun
something like
problem.
that, sloth or something. We saw
Not
what
even
it.
sloth. It's worse. It's worse.
Oh
Like do
god,
this.
this is looking
Oh
bloody.
damn. Looks like some complex plane thing.
Well, this is a sort of geo I don't really like.
It doesn't
Okay,
look like
wait.
a
So if you
geo.
don't
Wait,
see, wait,
don't.
I will also show you people the other geo. I will also
Okay.
show you people the other geo. And then, like, if you like the second problem better, we'll do that. Like, I personally like the first one
Wait, the
better
second
because
one,
it was
it's pretty
fun.
The
common,
second
right?
one. The second one.
Conventional. Conventional this is.
Yeah,
Yeah,
yeah. The
yeah.
second problem is
Just
It's
conventional.
an
And like,
ISL.
choose
It's an
quick. You don't
ISL
have to.
G2 or G1,
It's a
G3.
G2. It's a G2.
The G2, right? Like 2017 to 2014 range.
No, it's not in that range. And have you solved the problem?
No, I remember trying it once. I haven't completed it.
Yeah, then it's fine now.
Yeah, fine.
Yeah. So, like, do you want to do the second problem or the first problem? People.
Second.
second.
Like, it was so unanimous. I like the unity somewhere. Okay, so we will do the second problem. You
Wait, is
can keep this.
the first problem is also an ISL, my guess is.
Yeah, it might turn out to be something good.
Okay, first I would. Okay, so if like I don't know if I want to like spoil it. Okay, I won't spoil it, but I would say this. The second problem is essentially that if you consider, if you take like a polygon and consider random points on its sides and then makes these consecutive circles, like these are all points, and then make these circles, okay, then these four circles or like n circles for a general polygon will cover up the entire polygon. That is what the problem reduces to.
Okay. Yeah, oh, fine.
But yeah, don't worry about
It's
it.
not like it's easy even after that.
Okay, no, after this it's
Okay,
not.
you don't need to tell us. Okay, sir.
Okay, yeah, sorry. This is not what we are discussing, and I don't want to spoil a good problem.
But is it an ISL, by the way, the
Yeah,
weird
both
one?
are ISLs. Both are consecutive ISLs, in fact, of the same year.
Oh,
That means the other one's G3.
Yeah, it is.
can't
But
possibly
it's
be a
like
G1.
sufficiently old.
Which one are we trying, by the way?
Like no one puts such weird
Okay,
stuff.
the second one.
Second. Let's just do the second problem. I'll
Sure.
draw this as well.
Okay, you can actually
Okay,
bash this
people, and
doing
it's like
Bali or
I'm
something.
drawing with a stylus on a computer.
What
Oh,
do you
you
say, Nishant?
can't bash it actually. It's very hard to bash this.
I felt
I knew it.
He
AP,
was
BP, and
suggesting
CP are.
Larry bash.
Yeah.
Okay, it's horrible
You
I
can,
knew
stuff.
it. That's
you
the only
can,
thing he'll think about.
no, wait. You can compute KLM. Decent enough.
Fine.
Okay, wait, let me read problem, people. It's been like infinite time since I've solved this. It has this line feature which makes my lines straight. Okay, it's not working now for some reason. Like, did it get offended or something? What?
Jinxed.
I, I can't make lines without you guys. Just work. See. Okay, no, I remember this is some bad thing here. Yeah, so it's C-centric, it's not A-centric, sadly.
I think you can try maybe shift works.
Yeah,
It
it's
works on
C.
most things.
Yeah. It was
Like,
C-centric, right. I remember that because SC equal to SP, right?
yeah, we've seen
Yeah,
this
shift
kind of
does
thing.
work, it's not a problem there. The tangent is gamma at AB. Okay, so we have this line, which is, okay, horrible lines. This line, this is a tangent at C. This point is S, I believe. Then you consider the circle
One that you're
Your voice
slightly
is
breaking.
breaking, I think.
Yes.
this point is P. Obviously. Then you won't have to go through the terrors of my voice. Okay, that line is horrible. Okay, this is like good enough. We can work.
This feels like a projective thing, you know?
With all the stuff on SBA,
And Nishant, the problem with bashing here is how would you like? You would have to chord bash this. You can't complex because you need the condition SC equals SP. So you need P to lie on the circle centered at
You need
S going
4
through.
hours to quad bash this, I think.
I
No,
mean,
if
that's
you
a,
take like if you go with chord bash, you can easily do this. It's not hard to chord bash.
It's not hard, but takes time.
okay, we take
Yeah,
C as
yeah.
your
So
center.
like
We take
setting
C
is
as
just
your
easier,
center.
people believe
We
me.
take C as your zero origin, yeah. Oh, wait, C as origin would be good or what? I'm still thinking.
maybe C would
Okay,
be, or maybe
I would highly
SBA.
recommend. I would highly recommend do not bash this. Like I know it's tempting to bash,
Yeah,
but
fine.
at least for now, just don't.
Okay, so now define the intersection of the circle center of at C with radius SC, the second intersection as something. Define it.
See what dash
C
done.
dash, fine. So SC dash is the other tangent as well. So
True. This is also tangent. The
I wish this line function works on pen and paper also. Life would be much easier.
Sent diagram, and then everything else I just freehand because it just works. Like in fact, even when you're creating circles, always start with a circumcircle, and then the rest of the
then the rest
circles,
of the
if they
point.
are bad, you can just make them bad.
Mark.
Yes, I'm doing something.
Yes,
Sorry.
we learned that the hard way.
What? How?
After doing multiple tries of drawing a triangle and then drawing a circumcircle around it long ago.
Hi, like who? Why would you do that? That is so pathological.
Yeah, I got to know the same technique by Venture.
Okay, so CP is just the angle bisector, right?
CP, no, why?
See, I'm an angle bisector of KCL, angle KCL. It should
KC.
be. It should be.
True.
So we can join CL and CK
Yeah,
just
those
for.
I will draw for you. So you want this angle equal to this angle. Yeah, another general advice, any like thing that you're hoping is true, make it with dotted lines. Okay, and that doesn't mean that this circle is hope. I know that it exists, but yeah,
I mean, we do know that it exists, right?
we know that it exists because SP is equal to SC, so such a circle must exist. Like SP equal SC is given.
Right,
So
it has the radius.
yeah. Okay, I'm pretty sure I uploaded its solution there. Hopefully. Like this is a very well known or some problem. I don't know. This is like infinite solutions on the thread, including mine.
I didn't try it seriously actually, so I just saw it and it looked like a geo, so I'm like, I tried it.
Nice, nice, nice. Okay, people, thoughts. Because we are running out of time, so thoughts.
Maybe circumcenter of ABC,
Uh will that be good?
because you can get perpendiculars and stuff.
Yeah, but after you get perpendiculars, can you do any further angle chase with that? Like let's say that this is the circumcenter O. I join CO. I get that this is perpendicular. Can I do any further angle chase?
Yeah, wait, angle change might be a good idea actually now. We could just like work backwards from what we want, right? Because now we've converted
True.
it to angle condition. It's like KCM equal to KBM.
Wait, I need to find the razor. I can't use the razor. I use the razor. Yeah. So I will also draw these lines because sanity.
Okay, I see why.
Wait, why? I just drew them for the completeness of the
Angle
diagram.
SCM equal to angle CKM, right?
SC. Wait, just a minute. Yeah.
By the way,
SCM. Yeah,
can
yeah,
you
that's
use
a good
power of
thing.
point from the point S, like SC square is equal to SP square is equal to SB into SA?
Yeah, that's a very good thing, Aritra. That's like a great thing.
Yeah.
So people observe. Uh, SB into SA is equal to SC squared is equal to SP squared. That implies this angle is equal to this angle, or SP tangent to
ABP.
PBA.
Correct. Okay,
So we
yeah.
get that this angle is equal to this angle is equal to this angle.
Correct.
And also due to like alternate segment theorem, we have angle LKM. Wait, LKM? I don't think we have LKM, right?
No,
We have
CKM, CKM.
CKM, sorry. So I can just extend this.
So wait, so
Nice.
SPB is equal to LAB, which is equal to LKB.
Wait, just a minute.
Sorry.
SKM is equal to angle SCM. Oh, wait, CKM again. Okay, wait. Was this not a feature where it just like deletes it?
MCK,
Okay.
MCK. Yeah.
CKM, SCM.
MKC. Whoa, I'm also messing up my angles.
So we have this. So what next?
SPB is okay. So now SPB is equal to PAB, right? Yes. Which is equal to
Uh,
LAB
SPB is PAB,
by
which is,
Aritra's, which
yeah,
is equal to
true.
LAB, which is equal to LKB.
LKB, indeed. So angle LKB is equal to angle LAB. Oh, that's good, lab. Is equal to angle
LCB.
LCD. Wait, how
LCB.
LCB? Yeah, true. LCB, which is equal to angle SPB. Great. So also, in general, it's a good idea to convert your thing to something else. Like you want, wait, where did my cursor go? Okay, you
We got so
want
many
to
angles
show
similar, I can't read which one's which.
what?
I need to redraw my diagram again. We got like many equal angles.
Yeah. Wait, so see, people, we want MK equals ML, right? So that can be translated to angle
MCL
MLK
equal.
equaling MKL.
I felt that MCL equal to MCK would be easier.
By the way, Mandar, I think you like pointed the labels wrong because like AP intersect at K, you did like AP intersect at L. So the points label
That
Okay, you can
is
matters.
switch
like
A and B. You can
trivial
switch A
detail.
and B if you're lazy. Okay,
Like trivial detail.
fine. You'll have to
But
change it.
see, Aritra, like I did my angle chase with this, so sorry, we could just like.
Yeah,
Yeah,
it
yeah,
works. It
I
works.
can understand.
Thank you.
Wait, can we
So-
make a kind of a list of the angles we know which are equal?
Yeah, this list.
Okay, these are all right.
Yeah, these are all that we know. yet,
SPB is
till
equal
now.
to LKB. So
SPB
SPD is
is
equal to
LKB. Yeah.
LKP.
LKP, true.
So what does that mean? Okay, wait. I forgot.
That means LK is parallel to SP.
Yeah. Okay. Yeah. Good catch.
Okay, also, wait, what does it imply?
SP is parallel to LK.
SP parallel
Okay,
to LK.
that's good. LK parallel SP. Interesting.
And
Okay,
then
also,
LPS equal to, oh, sorry,
nahi speak. LPS.
equal to KLP or KLA, whatever you want to use.
Yeah.
KLA. Wait, how?
It's like a transversal intersecting LK and PS.
Oh, right. KLA. Okay. This thing.
LPS.
LPS. Yes, this angle equal this angle. Yeah, true. Okay, also, people. See, it would be a good idea to introduce MA as well.
Yeah.
Because we have that angle. Okay, wait. Have we done this already? Okay, yeah, we don't have to introduce this then.
Wait,
what
maybe
we
the
said?
arc would be nice. Maybe arc MA would be nice.
Arc MA. Yeah. So how do you intend to use it? Is the question.
Drawing another point, the circumcenter would not be nice. But maybe you can do something like, okay, we know that angle, we know that arc AL is
Arc
equal
A.
is equal to 2 times angle AKL, and MA plus arc MA plus arc AL is arc ML. So now if we show that ML is equal to MK, we're done.
ML equal to
Can't we-
MK is what we need to prove.
So that is what we have to prove as well.
So
The arc of MK is simply like the arc of MA plus 2 into angle of ALK.
AKL.
ALK, no?
I think
MA
it would
plus
be
2
like
angle
too
of ALK.
complicated.
So like we can just angle chase ALK, I think.
Yeah. Something. So arc. So okay,
Wait, people. So like, sorry, we are running a bit low on time, so I'll give you like hints. So given this, like, let this be X, let this be Y, and you find angle KML using these.
I
Like,
think I'm getting something else.
tell.
So like we have this angle 2 AKL plus arc MA is ML.
Okay, and
Now we can use MA is equal to 2 angle MKA.
yeah.
And now this MKA, if we can kind of like, it's just angle chasing.
Yes, the problem is essentially just angle chase now.
You have to like represent, you have to choose some nice angles and then you have to represent KLM triangle in terms of those angles.
Yeah, it shouldn't be too hard.
I think
Okay, what
what are
other
the main
angles do we
claims?
know
I think
about?
SP tangent to PBA was the main claim. That's it.
Huh. So how can we use that
MK.
tangency?
Can you find me this angle MKL? Like using these two, what I'm telling you is using just these two angles, you can find both angles MKL and MLK. Try chasing them.
Which two angles again? Which two angles?
Like the ones we want, like MKL and MLK. You can angle chase these two.
Yeah,
That's
I
what, like,
think we are just over confusing ourselves by introducing
yeah,
more things.
true, very true. It's like very not difficult, is what I would say.
Yeah, you just need to put
So A
like, I
minus
don't know.
X. So
10.
angle
Yeah.
LMK is equal to A minus X plus Y, where A is angle A.
Wait, which angle? Angle?
ML, I mean KLM, KML.
KML. Wait, we don't want KML.
Okay, fine. Then
Wait,
Yeah, then
wait.
just
Wait, what?
backward.
Wait, we need MLK, right? MLK and M.
yeah.
Okay, you could also get this angle, but how did you get this angle?
That's x. I mean, no, a minus x.
This angle.
No. Angle CMK is equal to CBK y.
True, it's Y.
And then the other one is angle LMC is equal to angle LAC, which is a minus x.
Oh, also true.
A minus x, not x.
Yes.
So that's all I did for the angle change.
True. But like, try to find these angles.
Yeah. I'm just going about the angle change.
Yes.
It's curious, but is LKPS a parallelogram, like eventually?
I'm not sure. I'd never used that.
Okay, no,
Which one?
it won't. It can't be. It's not symmetric. No, it's pretty symmetric actually.
Which quadrilateral are you talking about?
LKPS.
LKPS. Yeah, it could be.
It could be.
Yeah.
We haven't proved it, but it could be.
Like PL, although PL doesn't look exactly equal to SK, but fine.
Okay.
Maybe.
Wait, actually, okay, I just realized my solution is A oriented, so you can't find both angles using these angles. Sorry.
No problem.
Actually, you need this. Okay, wait, I'll like clean it up a little bit. What is this? Yeah. Whoa, no, not so much cleaning yet. Yeah, this is better. So you need angle PA is C. This angle, use this angle as X.
Damn, this is confusing.
And like we know that angle AKL
And
is equal to angle AL.
people just angle chase. Don't use my angle, just angle chase. Okay. Like, doesn't matter, just
Yeah,
angle
I'll just use
chase.
my angle.
Yeah, like just angle chase and find me a solution.
Like arc MA, you can use, since you know that angle MPA is equal to angle KPC, you can say that arc
Wait,
MA is angle
Don't
MPA.
use arcs, it's confusing. No.
Yes, exactly.
My brain doesn't work with arcs, it just works with angles.
Sorry, but don't use arcs.
Okay.
Yes. And you can continue the arc thing though. Yeah.
Need to
So
prove
arc
P
MA.
is equals to PAM, right?
So
What?
MA, arc
PBM.
M.
MA.
So
Wait a minute, Lavish. I'll come back to you. MA.
like so we know that angle MPA is equal to angle KPC. Right?
Wait.
Angle MPA.
MP. Wait, why?
Oh, MP, I heard
Huh?
MB.
Is KPC.
Huh.
Why?
All right, we haven't proved that. Okay, fine. No. Like, okay.
Oh,
We have used the fact SC equal to SP, so we don't care about any lengths anymore.
No, like MPC are is collinear
Yeah.
and APK is collinear.
If
So by
it's not. I believe you mean LPA. This is K. This is K.
oh, okay, yeah, my bad.
Yeah.
So LP is
Okay, let me try to angle cheese as well. Yeah, humans. Firstly, see this. If so, wait, I should not use backspace. Yes.
Are you telling the solution?
No, I'm just like do you have anything, Lavish? Like you were also saying something.
No, I'm just angle chasing. I guess it's easy, but I'm not able to find it. Just, I guess I need time.
Okay, so it's 29. We could extend it by like 10-ish minutes, 10, 15-ish minutes. Then I also have a class to go to.
Yeah, I'm fine with it.
Yeah. So like, is everyone fine with a small extension? I don't think there are many people either way, so it
But
should be
Yeah.
okay.
one thing isn't where K is, should it be L? Shouldn't that be L?
Yes, that Aritra also pointed that out, but I just okay, my diagram skills are very bad. That's the point. I'll wait. We will like we have all this, but just replace L and K everywhere here.
Okay, fine. Then, replacing that, then like because I was working with my diagram and I
Yeah.
have L
So
and
we
K.
have this angle equal to this angle, I believe.
Huh. So
Yes.
arc MPA plus arc arc MA
Hmm.
be equal to arc wait K like I'm trying to use the fact to kind of like arc MA plus arc LC is equal to
LC.
huh.
Can you reach LC is the bigger question. How do you
Like
intend on reaching LC?
like you have that point P, so maybe you can use angle CPL or something.
CPL.
Huh.
Interesting thoughts. But even if you have that angle, how will you use it is the question. Like, I don't think you can relate to arbitrary angles with the, like, you can't relate an arc to an arbitrary angle.
No, it's not exactly arbitrary, just the fact that we have P intersecting is making it. Although power of point of P would not be nice.
Yeah,
More-
yeah. Okay, humans. So, I'll give you another hint because we are a bit low on time. Uh, you see this angle, right? Also, like, sorry, my diagram is a little inaccurate, so looking at my diagram would be better. We have this this angle. See that
Huh?
this angle is equal to this angle, and this angle is equal to this angle. Can you find both of those angles?
Like angle, the double line angle, so angle BKM in
Hmm.
your diagram is equal to angle BAM.
True.
So angle LAM is
Hmm.
equal to angle LAB plus angle BAM. So
Also true.
that's going to be equal to angle LAB plus angle uh, BKM. So
Oh,
angle and
yeah.
that we can also get directly because we know that angle LKM is equal to angle LAM.
True.
So then angle BCM, where can you make that so that so angle
Okay.
BCM is also equal to angle BAM. So that means angle, so you know those are equal.
Yeah. I get what you mean. So you're just saying that this angle is equal to this angle, right?
Right, but what are you asking about those two angles?
Okay. Also, people, if you don't want spoilers, like I think you should leave now because this will. Okay, like, are people okay with getting the solution to this?
I would like to try it.
Yeah, I'll come back to you later, I think, on Discord or something.
Yeah, like because just randomly giving of a solution without much motive, like without letting you try, because it's a good problem. It's not particularly difficult. It isn't particularly easy. So yeah.
Fine
Wait,
then.
angles CPL
Hmm.
minus angle CAL
Yeah.
is equal to angle MPA.
True.
So that means arc MA,
MCA.
no MPA.
Okay, also humans. I will give you. Okay, so like I'll give you like one parting gift, and that is okay. Where did my stylus go?
I'm not hearing
And
you.
my
Yeah.
parting gift is you can like write all the angles using just this and this angle.
Okay, yeah, I'll just continue my thing
Okay,
once.
sorry,
Yes,
sorry,
Nishant, you
not
were
only
saying no
this
problem,
and
no
this,
problem.
this and this angle. You can just use these two angles to write out all the angles in the figure and get the equality.
I see. So like angle, okay, yeah,
Okay, wait. Do you want to wait? I'll like
yeah.
reshare. Share. Yes.
So Nishant, you were right. So basically, you have angle CPL minus angle
Hmm.
CAL is equal to angle MCA.
True. That is indeed true.
So that means arc MA is equal to angle two times angle CPL. If you can write it down. I actually get a bit wordy after this.
Okay. Wait. So arc MA.
Is equal to
Hmm.
two times angle
CPM.
CPL
L.
minus two times
Yeah.
angle CAL,
TAL.
and two times angle CAL is equal to arc what? LC.
True. True. This is arc LC. Negative two angles CPL. This is indeed true.
Right. So if you look at arc
ML. Yeah.
ML is equal to MA plus this two times angle AKL.
AKL. True.
AKL or ALK, I don't even know which
Yeah.
one it is.
Like I get the point. I get the point.
Wait, which one is AKL according to your diagram? Is that right?
Yeah, it's AKL, so it's not correct. Like
Okay, you
like you
can.
mean this one, right? You mean this
Huh,
one,
huh,
but my
huh.
diagram isn't correct. I get the point. Yeah.
Okay, you can change the wording then. We'll go
No,
with.
no, it's fine. I understand your wording.
So then you can substitute for MA, and what do you get for that?
MA, you would get twice angle CPL plus angle A. Okay, wait.
Okay, I got the angle chase. Yes.
You got it
Oh,
right?
I switched off the volume completely and I got it. Yeah.
that's great. That's great. That's great.
So now with this, wait, which arc is the LC? Yes, okay. So now what you can do is we know that that's equal to angle PCS,
Which?
the CPL plus AKL
Yes. It's angle CPS.
minus arc LC,
Yes.
and we know that's MK, arc MK.
Oh, damn, yes. Wait, why do we know this? Like, wait, CPS. How is
Okay,
this?
not MK, ML, but fine.
But yeah, it is ML. That is
ML.
true.
Fine.
Like we started with MK and we show that it's equal to ML.
How
No,
did you
we
start?
started with ML only.
Wait, angle CP. Okay, the L which you wrote in the beginning was
Okay, so like there has been some diagram issues, but this is like a way slicker solution actually. Wait, where did you use the fact that CPS is equal, like these two are equal? Where did you use
And
this?
you have to use it, right? I mean, I remember using it.
Yeah, you have to use it, otherwise like you
Okay,
can't prove it.
SCP you can use as CKM, right?
wait, I did use that somewhere. Wait. No, I think I just used the fact that it was tangent to the circumcircular
No,
PPA.
that's not sufficient. I can.
Nahin, that is sufficient. Like PBA,
That is
we did
sufficient.
derive that.
But
We did
how did
derive it
you?
from.
But in the angle chase, I couldn't complete it by just using that. I had to use the angles were equal as well.
Yes. Like normal angle chase, you have to use.
Yeah.
Yeah, okay. This is like a way slicker solution. Great work, man. Like, yeah. I
Wait, so
just
wait,
preferred angles though. I just
wait, so
prefer
how did it
angles.
work? MA, bro, how do I understand that? Wait, MA is
Okay, wait, people. Like, I'll close the recording now because obvious reasons.
Yeah.
wait,
Uh,
can you show the solution? I'll take a screenshot or something.